welcome everybody. Let me just set the system up itself. So share this. Yeah, so what I'm going to be doing, I'm going to give you a quick history of artificial intelligence, where we are, we're going to head to, and how to use it in different ways. So that's my plan. So if you go to the early foundations of artificial intelligence, it's really around about the 19, you can go further, but it's around about 1940, 1950. What happens is that we've got a chap called Alan Turing, and he's thinking about how can machines actually think. So he devised this machine called the Turing machine. And with that, it's a very simple model. And from that emerged a lot of the computing, how, the computers were developed. And also he developed something called the Turing test. So let me just show you here. So what the Turing test is that, say, for example, there's a person in the middle. He's talking to either a computer or a person he doesn't know. So right there in the middle. And what happens is that he asks the computer or the person, whichever is there, switched on, various questions. And then from those various questions, he's got to figure out, is he talking to a real person or is he talking to a computer? So this test basically ran from the 1950s onwards, and it wasn't passed until recently. I think by 2024, last year, or 2020, early 2025, this test actually was bypassed, and people couldn't tell if they were talking to a computer or actual human. So so we had this basic test to figure out. There's no other real tests available to understand what a computer is or what a human. So basically what this means on this test is that you can't tell the difference between a human and a computer. So what happened early on, the first approach was to use symbolic or logic reasoning. So what this meant is that they thought that they could conquer or get artificial intelligence using language, symbols like words, breaking words down or sentences down into, for example, verbs, nouns, and looking at the different possibilities, how they go. That was the main approach. So a lot of years were spent just symbolically doing it, on using logic, basically. So what happened then is that these systems, these symbolic systems, were quite brittle, in terms that if you ask it a certain question that it's not used to, it will break down and it will give no answer. So that was a problem with the symbolic type of approach. So then there was another era. So they tried to do more probabilistic, if and then rules came, like here. So logic rules, more and more if and then logic rules came in. They worked for a while, but again, the problem was if you asked a certain questions, it wouldn't. If it didn't know the answer, it would just either give nonsense or not answer, and it was very limited in knowledge. So we had these expert systems being built previously, and they couldn't answer all the types of questions. Then we move on to the neural network area. Now, there was no way that anybody knew that this is going to work for language when they started. The real inspiration was the human brain. So they looked at neurons, and they were looking at how neurons talk to each other. So we've got, I think, 100 billion neurons in the human body, in the human mind. And they're connected. So each neuron, so if we take one little neuron here, is connected to thousands of other neurons across the brain. But what they did is, if you look at this diagram, is that they just did a simplified model. They didn't do thousands, they just done it like a few, like 20 or 30 neurons or even 10 neurons. So they had a very small model to start off with to see. And they gave it information, like, for example, this one's like forecasting the weather. So it's got different inputs here. There's the input layer, they got the hidden layer, and they got the output layer doing a prediction. Now, what happened is that most of this was working fine, but it wouldn't give you good predictions, because what we didn't know at that time, or most computer scientists didn't know, was that they needed to give it almost millions of examples. When we did it, the type of computers we had in the early 90s, they weren't that big, and even data wasn't that available. So what the main thing was, as time has gone on and we got more and more powerful computers, is that we give it more and more data examples, and they somehow seem to work. Yeah, and then we had like statistical rules being applied, and they with massive data sets. So what I'm talking about massive is basically the internet. As the internet got, the whole world got digitized on the internet, they could go in the computers and they could read almost the entire, like Wikipedia, all the web pages that became available. So a huge data set became available. That's one of the most fundamental things as well to understand. This couldn't be done without that access to all that particular information. Then what happened is there was a breakthrough in about 2012 where we got the AlexNet. And this one was able, this program was able to recognize images, really. Like, for example, you give an image of a cat and a dog in different poses, and it could recognize the difference. So here's a little example of what AlexNet looks like. So you've got different layers of the neural network. Like basically, this is a representation of the different layers, and these are quite large. I mean, they're starting to extend longer and longer. That's the reason for deep. Before, the early neural network works were actually quite shallow. Like they had a couple of layers, and that was it. But now, as time goes on, there were some other innovations in terms of how the neural net worked, what the connections were, how to do the connections. So a lot of improvements were happening slowly, yeah, and incrementally. But then with this AlexNet, it was able to recognize objects. So now, like, for example, Tesla, they go around looking at the road, the cars, and they can see, like pedestrians or traffic lights. This is the basis of it. I mean, their models are a lot bigger than these now. Then what we got is in 2014, what they call generative adversarial networks. What these were is that you give an image and it can reconstruct that particular image from examples. Yeah. So that was the generative one. And then there was further on something called AlphaGo. What happened here was, if you know the game Go, I can show you what it looks like. I'll just show you what it looks like so you understand. So this is the game Go. Basically, this is a Chinese game. It's been there for thousands of years. It's like chess, but slightly different. It's got more combinations than even chess itself. And the Chinese play that. What happened in that particular Go game? So basically what happened is that this Go game, the neural net was able to beat the world champion in Go. This is in 2016. So we were really moving into a territory where it could start beating computers. I mean, computers could beat humans at expert level. But the only problem was here still is that when they built neural nets, they were basically very narrow space. What it means that you could do it for Go, you could do it for chess, or you could do it for a particular area, but it couldn't generalize overall like a human can. So if you put a human and you say, well, learn, chess, learn Spanish, drive a car, they couldn't do that. What's happening now is that we're moving away from very narrow, like examples, to generalized. That's what's moving on. So what's happening is that the number of parameters, these are the, like, for example, if you look at the connections here, the number of connections, you can say, is going into the billions. So you've got really big models, huge models, AI models, and they're able to have almost coming up to human type. I wouldn't say exactly human, still far from human, but significant bigger models. So what happened is that what they did is that the breakthrough happened in around about 2000 and I say 20, where they started to apply neural nets to language. As I said before, language was being used symbolically, you know, like if and then statements, you know, the normal conventional way. But then they started using neural nets, and they got this huge neural nets that could be applied to the whole internet. So let me go into that part. So let me go to the understanding of how language, or what language is. So when we got language, it's basically, you know, a bunch of words, and those words are all related to each other in terms of, for example, take a sentence. For example, you have a sentence, and these words can be added or taken away from a particular sentence. And the problem with language, or the difficulty with language the computers had, is that you can have a single word that could be used in two places. For example, the river bank. For example, the river bank, or I go to the bank. Now, the computer doesn't know, the early computers didn't know what the word bank referred to. Did it make the bank of the river, or actual bank? So this is the thing. It was a context problem. So the early AIs did not know, or the symbolic way, how this word is being used, because we overload a lot of words in English or in other languages as well. So let me just go here. There's some, people that were, if anybody knows Noam Chomsky, he's the one that was advocating for symbolic approach in computing. So let's go in. So they're all done symbolic ways. Let me see that one. Then we got the new guys. These are the neural networks, a different approach. So we got Jeffrey Hinton and Yoshi. These guys were actually pioneering and using a different approach to tackle the same problem, basically enabling neural nets to actually learn things, or language itself. So the whole problem in language, as you can see, how does anybody know what it means? We call that meaning semantics. There's no way of, when we say a sentence, or, you're listening to me, you're understanding what I'm basically saying, but how does a computer understand? Now, the thing is, there's no way of figuring that out. Eventually what happened is that people were tinkering and doing different things. They started to look at words, basically. They call it word embeddings. So, for example, word embeddings, let me just give you an example what they are. So, for example, they looked at every combination of two words, how frequently they occur in the entire English language. For example, they take all the books, all the internet, and they combine and say how frequent, say, for example, large, would A work with large, or these two words combined. This is called a word to vec. They'll look at the probabilities, how these words, each word with every other word, combine itself. It's called word to vec. Now, from that emerged an idea to actually, let me explain this one. This might be interesting. All right. So example, you got man here. Here's an example, man, king, woman, and queen. So what happened is that the idea was to convert language into mathematics. That hope everybody understands a little bit about vectors. Vector diagram is like O-level standard or metric standard. You got these vectors. So you got a vector here representing a word. So language was converted into mathematics or vectors, and that was then represented as the meaning was given by mathematics. For example, if you got here king, there's a vector called, this is a random example. So you put in king and it's somewhere here. And then you got another vector called man, and there's a distance between them. Yeah, there's a vector, actually mathematical distance between these two vectors. You can minus man from king, and it actually would give you queen. So the basic idea is to convert words into vectors. As you can see here, these are mathematical way. So basically, words are converted to mathematics, and then you use mathematics as meaning. That was a novel idea. And here, what we got is, this is basically breaking down everything into tokens. So the large language modules what they do is break everything down. Can you see these different colors? You can see these different colors in the language. They've been broken down. So some parts here, like large and the space, you got language and the space, and then you got the brackets and a dot as a different color. So each of these, instead of doing words, there's a special thing called tokenization. So language is first broken into these tokens. And then from these tokens, you got these vectors. So each vector, a dog, they'll be like, and these vectors are not that small. Over here, this vector is like 4, but the ones they use in large language models, they're about 4,000. So basically 4,000 of these dimensions are used. To very high dimensional. And what they do then is to run these neural nets over the whole internet, basically all the literature they got over thing, and then build these vectors up. So they break the model into little components, as you can see here. They break it down. The language, what they call is tokenization. This part is called tokenization. And each of these tokens, not actual words, but these tokens, like different sections of the tokens, are given a vector. And these vectors appear in space. Now, from this mathematics now, you can actually look at how you can infer distances. So how far, for example, you get king and queen would be maybe together, man and woman might be together. But if you even minus it using basic takeaway, you can take away things and you can infer different ideas. So basically, the meaning comes from mathematics. That's what I want to put across. Yeah, there's huge vectors in, it's all mathematics going on in the background in large language models. For example, we got here, king minus male, royalty equals male. So literally using the minus, you got words, so you minus them, you actually get a meaning from it. So basically, meanings emerge from mathematics. And this is the main critical idea, how LLMs are working. So again, you got queen minus royalty, you got female, you got man minus male equals common person. Female, a woman minus female is common. So, on pure mathematics. I mean, this is 2 dimensions, but the dimensions we're working is like 4,000, there's a high dimensionality. So that's the main idea I wanted to project across. So you do embedding vectors and then you project it. Then you pass these into a neural network. Let's go on a bit. And then these networks are getting larger and larger at the moment. And what's happened is that as they put they grew these networks, into the billions or trillions. What's happening is that they didn't realize, right? What happened is that as they gave all the information on a larger model, it somehow had an emergent property, like merged, and it was able to do things. For example, they gave it like all the internet, and suddenly they found and asked a question. For example, how do I do this in a particular software? And it was able to answer that question, even though no one taught it. So somehow something emerged. So what you got basically, even though you're passing these words in or tokens into the neural net, and you're using some simple things to predict them, inside the neural net or the LLM, large language model, it's built a model of the world itself. And these models inside somehow understand the world itself, the world, how things operate, even though you never taught it. This is the main thing. And then we're trying to figure out how that's happened. It wasn't like they went out and did it. They just gave it more and more information with a bigger and bigger model, and it picked up and was able to understand things that they never taught it. I'm just going through that. So this is what they call emergence of semantic understanders. Semantic means meaning, basically how you get meaning in neural nets. Let's go on. So that basically explains the basics of it. Let's go in. What I'm going to do now is move on and see how you can use it. I mean, there's a lot of background. I'm just doing a very high level at the moment. Otherwise you have to go to deep mathematics. So the next part of the talk is to be able to use the large language models or LLMs to actually do useful information. So what it is what they call prompt engineering. So here's an example. So here you got the prompt, is your prompt, and you want to put something in there and you want to get information out. This is what they call prompt engineering. So let's go here. This one. So prompt engineering is coming more available, or it's another word, we call it context engineering. So once the model has been built, what you're going to do to get good information is to ask it a particular question. If you give it a very generalized question, it would just come with general information. You got to go and ask it very particular type of information. That's what's called prompt or context engineering. So you got huge space, huge dimensional space, and what you're going to ask it, for example, if I was saying, for example, in Islam, I would say, if I say you have, I would just say to the thing, let me just show you, for example, might be better. So I say, you have, say, 20 years of teaching say, for example, that. Well, I'll just do spelling. So you, for example, this is the context. I gave it, rather than just asking a question, I have to say, you got experience in that area. Or say, for example, if you're a lawyer, you say you have 20 years of lawyer experience in a particular lawyer. What this does, this little sentence, is it gives you more information. It goes to that context in that area and picks up that experience rather than just asking a simple question. So we'll do a couple of them in a minute. So let me go back in. So let's have a look. So what you basically need is simplicity, means that asks, don't put too much jargon in, have a simple structure. Now here, let's just do some examples. I think better to just show you examples. What I'm going to do, I've got some examples here. So what I'm going to do first with the exposition of the Quran. So the problem you got also in AIs at the moment, or large language, is a hallucination. What it is, it makes up things. Yeah, they're only now figuring out how to overcome that. So this hallucination, it gives you answers that not really appropriate, or it makes up answers. That's what hallucination. But to avoid that, in our case, what we normally do, I've actually downloaded the Quran. So what I'm going to do here, I'll show you an example. So what you do, if you click this button here, this is Chatgpt. So you've got you can go directly there. I've actually got membership. So I've got the pro version or membership. So what I'm going to do is add in a file. So it's coming up. Here's a file, as you can see. And I've got right here, I've got a doc file, a document basically of the exposition of the Quran. So now it's reading that doc. It's a whole exposition, but it's only in text. It's not the PDF version. It's a text file. So now I've got that. What I can do, let's ask it a simple question. Okay, I'm going to ask it this question. Break the Quran into thematic categories. How many will there be? So thematic means that meaningful category. We say the Quran is sometimes split in different areas and you got things here and there. We want to collect everything together. Let's see what it does. And I can say strictly only use the doc. Even if I get spelling errors, like for example here, don't worry about it. You can add that. But the LLM can overcome those spelling errors. So don't worry too much about spelling errors. So if I do that, let's see what it does. Just going to read the document and then it's going to try to figure out what I mean. Yeah, so it's got a number of them. Can you list them? Can you list the first 50? So it's now, I'm just giving it first 50. Just picking out the first 50. All right. Then I say, I don't understand this. I say, explain. So you can query it. Explain what each means. So it's gone in. Now it's going to be all the meanings, for example, what it thinks from the document itself. So if you don't say from the document and strictly, it will pick up all the information from the internet. So you'll get, other versions of the Quran. But here you get the other one. So you can see it's picking up all the information. Let's do another prompt. I say, look at this one. I built these prompts up already. That's that. Right, let's see that. Now this one, I said, analyze the document and list all the prophets, explain what they achieved. Just a simple prompt. You can do that. So now it's going in and explaining each one. So you can see each one, and then you can apply these as well. You can say, for example, if you got a query, how would this prophet apply this in this situation? You can ask that question as well, and you get an answer back. Yeah, and I want to say list the surahs and the AYA. So you can even say that. So you can list the surah and ayats where they appear. So you give you all the references straight away. So it's very good at picking up information and giving you references. So wherever you need the references, you got those references. How's that? Let me see. Let me look at some more prompts I did. Here's a bit more example. Explain the Prophet Yusuf story and explain what it implies. So if you want to construct an argument, for example, if you're having an argument or you want to argue a case or something, you can literally construct it. Here, this is an example. So it explains the Yusuf story, what it means. And what you can do is relate it to modern things as well. Like if you've got a situation, you can ask it, in this situation, how would I apply, or which prophets, area can be applied in this particular situation? I mean, you can literally do that. I mean, it's up to you, whatever your imagination is. I've got a couple other prompts I could show you. Let me just move that one out. It's just underneath, I can't see. So here's an example where I said, provide that, like 20 years of theological experience. You can construct an argument. For example, if I wanted to construct a detailed argument, I can do that. So you can do it at basically a theological level if you wanted to do it. So just do that. And it generates you that in seconds. So, any references, anything, you can pick up and apply them to real world situations even now. Or, for example, if I say, compare. So I got, for example, here, the hadith. I've got a document. So this document is all the complete hadith. I'll just show you it. And I say, and I can load the Quran up as well. That's the Quran. So I've loaded the exposition and had completed these. That's in a PDF file. Then I can ask, does anybody want to ask any questions? Let's see if it answers live. Has anybody got a question they want to ask?
Final contradictions.
Find all.
Sorry, is this Chatgpt?
Yes, this is Chatgpt. You can do the same with
Okay.
I've got Grok here. Like here's Grok. You can do Grok, or you can do Notebook LLM as well. You can put on this version, you can put about 10 documents in for example, the Google version, you can put 50 in, like 50 documents, and you can ask it questions on 50 documents. The Pro version in Gemini, you can do 100 documents at a time, your own documents. This won't work too much because the way they limit this, so if it's too much information, you need to do a bit of programming. Because I've tried this before, it won't find all the contradictions. If it's too many, it sort of like resists. So what the best way is, you have to go like surah by surah or ayat by ayat and ask it. There's a way to do it programmatic because it costs them a lot of money. You know, like this version, if I ask it to do that and to do 2 documents, it's going to take them too much tokens. So that what they've done is limit. So the answer is probably very limited. You can see it's not that many. So what you have to do is program it, or you have to go list the so go each surah, and if it's a long surah, break it down and then ask the question against each one. It's to do with the way they limit the information. Otherwise, it'd be a ton of information, and it will cost them a lot of money. So you can do it, but it's the way you approach it as well. Let's have a look at something else. All right, let me give you the other example. I mean, these are prompts. I've got a number of prompts there. That will prompt there. So you can see I'm using words strictly to do with your documentation. You can use that. There's another one out there. This is what we call Grok. You can do the same thing with Grok. You can load up. There's sometimes in Grok could be even better because it's got agents now. So Grok is quite powerful. Yeah, they keep moving. You know, the thing is moving all the time. So if you think, for example, this is today, by next month, it'd be something totally different. You know, it'd be more powerful. So don't think this is the only thing you got and this is what it means. By next month, it's already shifting, maybe 10 times faster, 10 times better, more detail. And then in about 18 months, it'd be 100 times more. So nothing's standing still, as you know, it's a constant moving. Let me show you another example in Notebook LLM. So if you go Google Gmail, it gives you free access to this. So try to get Gmail, go here. I've got Gmail, so I've got access. So let me give you an example of what I've done. So I've done exposition, I've done that. I was doing some research on them, but it's pretty good. So this one is, what's his name again? Allama Iqbal's book. So I've loaded up all the chapters. So I divided all the chapters. I got the chapters. So if I want to say chapter 1, I can ask it certain questions. So what it can do is quite powerful. You can even create a video. So if you want to create your own little video about this chapter, it can actually do that. So it can just say run a video. So it says do that. It can even do an audio and analyze it. Here's another mind map. And you can generate all these reports. So if you want to do a study guide on that chapter, it can generate you a study guide. You can do a blog post. You can do a research proposal. So these are just ever increasing new things. So you can do more and more research with these. So let's just do a study guide. I should show you. This might be quick. The study guide. So it's generating these reports. And all these have been done previously. So for example, if I just look at this, it's a mind map. So it goes in and, you know, it tells you which part it's picked out, the important information. You know, what's religion, which one's philosophy. So you got mind map of the information of your documentation. Well, that's that mind map. Let's go back. Let's go here. So it's still generating, you know, the videos. It's going to take some. So we got here, let's see, reconstruction of thought. Let's look here. So it's broken up. So you can go through, you can literally put 50 documents in this free version here, or you can put 100 documents or 200 documents in the paid version, and you can ask questions. You can generate information from that. There's another one. Let's look at the Quranic exposition. That's what I was doing. So I was doing some research here with the exposition, and then it was generating everything. Let's have a look at this. Here's a study guide, for example. It tells you what areas to study. It goes through the whole thing. So if you don't know what you're looking at, it can generate a whole study guide. And interestingly, let me see that one. Is it got? Oh, here. This one will show you.
Am I right to say that this is an aiding tool? It's not a leading tool. In other words, anything that is given to you, you still need to validate.
At the moment, yes, you still need to validate. I mean, you're going to have some, because it's still got a bit of hallucinations, but you should have that much knowledge. I mean, to pick up what's hallucinating, if it's, you still need that. But that, I'm saying, in a couple of months, that's already being reduced. They've got new techniques, new out there. But so if I say in about 3 months or 6 months, the hallucination is going to be really minimized, that's going to change already, because there's an area they've identified and already lots of people tackling it. So at this moment in time, there might be hallucinations, but in 6 months, it might be very less. Do you understand?
Yeah. It's still evolving. I mean, that's the key thing. But like anything else, you can't take anything face value. It's a brilliant tool. It speeds up your research, but you still need to be careful, or you still need to, check the information.
Yeah, if you do strictly, I mean, there's ways you can overcome it. I mean, there's programming ways that there's what they call graph rag. There's graphs they build up of knowledge, and they cross-reference from that PDF file. So then it checks if that actually exists or not in terms of his knowledge. But 99% at the moment is coming right. I mean, you can check the references and check, you can go through the references, what's generated, and just check if those references are correct.
Yeah, I mean, like now you're uploading a specific document and you're asking to read and respond.
Yeah.
Now, if you're not careful and if you're not specific and it goes out onto the web, it can pick up anything.
Yeah, but this one here in the Google LLM, they're based on the documentation. So this is based on only the documentation. It won't go outside. The way this works is whatever your documentation here is going to talk about this particular documentation.
Right.
Yeah.
Right.
There might be still quirks, so I wouldn't say it's 100%. No one can say it's 100% right now. We haven't reached that target yet, but it's like 99%, you can say, mostly. Yeah. The longer you have, what happens is the longer the context window. I mean, as you ask it more and more information, if you say, write me 10,000 words, maybe near the end, it might start becoming, inaccurate. Yeah. Does that make sense? Yeah. All right. Any other questions?
One thing I spotted is when you did a search about the prophets and against Hazrat Isa alayhi salam, he used the word miraculous or something like that. I didn't quite.
Yeah, you can ask it. Yeah, that's what I'm saying. It might have those things because it's picking up some stuff from the internet. It's picking up some stuff from, you got to query it. Sometimes you still have to have that knowledge. You can't trust everything. No one's going to trust this 100% yet.
That's the point.
But it's a tool. Yeah, go on.
No, that's the point. And it's a brilliant tool. It speeds up a lot of your research and it saves a lot of time, looking up references and stuff. So, yeah, I agree.
Yeah, you can cross-reference things,
Yeah.
You can construct arguments, construct arguments. You can extract all because it goes through the whole documents and you can construct, but you have to, individual person can't have that time to look at every single line of the Quran and, and cross-reference everything. This can do that. It can pick up information that you didn't know. That's how you use it. It's a tool basically at the moment.
And is any of this research and searches get saved in the back? Is there any risk that we need to be aware of?
Like what? What do you mean?
So you're doing your searches, you're looking at information. Is any of this stored somewhere in the back, or do we need to be aware of something, or is there any risk that we need to be aware of?
No, it's just online. I mean, there. I mean, look, everything that you type in, or all this information we're having on, for example, what's this again? Zoom or WhatsApp. Everything goes through, all the agencies, right? So nothing that you're doing on any phone, computer that's not going through any agencies, right? So don't put anything that's, you know, that can be dangerous. You understand?
Mm-hmm.
People don't realize that. You know, I mean, if you're just doing research, that's not going to do anything. This is available anyway. Do you understand? This is in any library. Has anybody got any other questions? Oh, you just have a Gmail account, yeah, and then you just type this in, Notebook LLM, or here. Just go this. Okay, no. Just go Notebook LLM Google, and it just come up here, yeah. And it'll come up, and you can generate like loads of things from this. I mean, there's tons and tons. You know, it can generate you audio. It can have, you know, conversation audio about what you each chapter. You can highlight. I mean, they come up with things that you don't even think of. You know, it can give you ideas. It can even now generate videos on that. You can output videos, and you can do like 50. And this free version gives you about 50 documents. So you can put 50 documents in. If you want more, the paid version is like 200 documents of your own documents at a time. So each of these, for example, you can put 200 documents on the paid version.
Yeah.
Is that okay?
Yes, that's like 50 at one time for one specific query.
Yeah.
Right?
Yeah. One like here, I've got here 7 chapters. Yeah. Yeah. I mean, I could add everything in, you know, from to Islam. You know, if you've got 50 documents, you can put everything. I can put the exposition in, all the others. But what I found is better to do. It's actually, if you narrow it down, sometimes it might be easier. Like look at chapter 1, more detail, more specific detail. You know, going into specific detail. But you can do it for everything, and it's ask that general question. Put that in, and that could be your, you know, analysis tool. Any other questions?
Yes, sorry, Jaz bhai, go ahead.
No, yes, looking ahead, I was thinking that how can we, the way we have interpreted the Quran, that is Allama Parvez, it is more on the system. And presently, once we do the search, all kinds of, you know, translations are consulted and these things show up. So something on
the way, so no, the way you do it, for example, here, like this one, let me see.
So I think we can say that only quote from Parvez's work, isn't it?
No, but you have to give it a documentation. It won't do it from Parvez's work only. That's what I'm saying. Use a document in Chatgpt. You'll have to upload, for example. Let me just do a new one. So here, if you upload the document, so we got this document here. So here, and I say strictly apply from this document, then I can do it from this document. Otherwise, it will go, if I don't have this document, I just say Parvez, it might not know. Do you understand? It could be any Parvez. Do you understand?
Good.
And it might pick up other things from the internet. Do you understand? Because it's got the whole internet. It's got thousands, you know, millions of books in there, and it can pick up any information. You have to be. That's why you use documents. Yeah.
Okay.
And same with Google LLM. That does it again. You load the document up. You can ask it particular questions on those documents. I mean, you literally can put all the, you know, the previous Risale in, for example, to Islam, and then ask it questions on those ones if you want. You know, those are the type of things you can do. There's a good research tool. I mean, even research is changing because of this. Other questions?
So, Riyad, does it do other languages? Is that what you're saying when you say Risala? So, if you put Urdu stuff in there, does it?
Yeah, say, look, let's go here. I mean, I can say in Urdu.
Yeah.
So let's go to here. Yeah, it can do any language, basically, any language or any other language.
Right.
I mean, the way it was constructed, these LLMs, they were actually at the beginning language translators. That's where they emerged from. So they were trying to do language translation, and then they found out that it can do other things. Yeah. So if I say list prophets in, so in Urdu, yeah.
Yeah.
That doesn't matter about list. See, I've got a spelling mistake because it's probabilistic. It knows that where how this I'm using list. So don't be afraid to use it. You don't have to correct the spellings 100%. Some people are correct. There it goes. So this looks more like Arabic to me, doesn't it?
Yeah. Is it Arabic?
This looks a bit like Arabic, but I don't know. Let's see. Let's move this out the way. Let's see and say this. You could tell it. This.
You would say messengers rather than prophets, right?
Yeah, like.
But I can see in at the bottom.
More like.
It's the way it's written.
Well, I could tell it. I could query it. I said it doesn't look like.
Yeah, no, it is Urdu.
Is this Urdu?
Yeah.
It look. I think it's got the Arabic type font. That's probably what it is.
It's got Arabic font, but it's Urdu.
Oh, it's Urdu. Oh, okay. Yeah, so you can do it Urdu. You can do it right.
I think you can get different fonts as well. This is a different font.
Yeah, you can put different fonts as well. You can write in. I think Punjabi. That's how you spell it. Yeah, you can do it in Punjabi. You can do different languages, literally any language to any other language. You could translate. You put one language in, it can translate out to the other one. Another thing you can do here, this one, I'm not sure if it's in the free version, but you got this voice model. You can put that on. I'd have to use it. It's not working now. Allow. Here it goes. Hi there. So there I'm talking to it in Urdu. Talk in Urdu.
Yes, you ho.
There's Chatgpt. There's Grok. There's
You got
Notebook
Grok.
LM.
Yeah, Grok.
Grok.
You got Gemini.
Chatgpt.
Notebook LM is like Gemini. Yeah. There's another one. There's Meta's one. That's Llama. There's Mistral. There's a number of them out there. So basically, you can even chat to it. Like literally, you got chat, and you can ask it questions. Yeah, there's another advantage. Any other questions?
Shah Sahab,
Yes.
just looking at it in the simplest form, the whole business of AI, it looks like human beings understanding themselves, how our brains are working, how we processing, how we, all the calculations and so on. In the simplest way, it's literally breaking down ourselves, understanding our own selves.
It is because
the verses of the verses of the Quran are coming through my mind. That just start even looking at your own self for the signs that Allah exists and understanding. That's the simplest of examples is given with regards to wealth. That the purpose of it is the example of blood is given, how blood circulates in our bodies. If blood starts to be concentrated in one place, it's known as blood clot, and you die. The body stops functioning. And in this, the whole breakdown or the whole history of AI or computing is, to me, is breaking ourselves into, understandable and manageable portions, bit by bit, how our brains are functioning, how the connections are made in millions and millions of connections. And that's how we can process, even look at something, and our thoughts can, overcome such complicated matters. So it's the same process, what is as computing, from a very simple point of view. That's one. Am I correct in understanding that?
Yeah, because it's in science, what they call in materialism, they break everything down to the basic units. You go to the finer elements and try to then understand how things are built up from that way. That's how science works at the moment. It's materialistic science. That's what it breaks down to. That's why they went to the neurons, trying to understand the neurons on the basic level. because it's like a black box. We don't know the programming behind it. Do you understand? Or what it was. No one knew. Even now, they don't know fully, for example, in the brain, what thoughts are, how a thought comes. What is a thought? Do you understand? They don't know the language of a thought yet. They can do individual neurons, like what the electrical output or the chemical output is, but they don't know, when we have a thought, what this thought is and how to capture that thought. Does that make sense?
Yeah.
We can do individual firing of neurons at the moment.
Sure. Thank you.
All right,
and
question. So here's a document I've got of the exposition. It's a text file. Yeah. And then it loads it up here. It's loading up here. Now you can ask it any questions. And you just have to say strictly using that strictly. If you don't use that strictly, it could go outside. Right. But if you do in Google LLM, it can allow you to only do that document. So if you do it here, let me just show you example. So I'll do it here. I say create a new. I'll show you a new book. So I'm uploading the document. I say here. I'm doing the exposition. So it's reading up the exposition. It might take a few minutes, or I don't know how long it takes. They're getting faster every time. So you got the exposition. Now, once that's loaded up, you can query this here.
Right.
So you don't need any other tool. Do you understand?
I see.
Yeah.
Okay.
This is the fastest way. Once it's loaded up, and it's loading up at the moment. It's reading everything.
Yeah.
Once it's done that, it takes a bit of time, and then you can query this. This is your best way of querying anyway.
But I think
this is it. This I would say this either here, Notebook LLM, you can do that, or Chatgpt or Grok. Once you got this document, you can query anything.
Okay.